All right, we're going to do composite functions. I want you guys to use these two functions for all four of these problems. I want you to give me these problems when you come into class. They might be ugly. I don't know. When you're plugging f into g, I do want you to expand it so it's not squared. Okay, so I'm going to show you guys kind of how to do this. What's going to happen is you're going to have a couple different functions. I'm actually going to do 3 of them. I'm going to do 2 linear and 1 quadratic. So what you're going to see is you're either going to see f of g of x in this format, which means the g function is going to be plugged in to the f function. Just like if it told me f of 3, I would take 3 and plug it into the function for x. This one, it's telling me plug in g for x. So that's the same thing as g equals this. It's the same thing as if they told me this, which we've done before. So this is telling me to plug that into the function. So that's what I'm going to do. -2 for x plus 5 plus 9. And then I'm just going to simplify. So -8x minus 10 plus 9, -8x minus 1. When you write this, you need to write this portion as well. So you need to say f of g of x equals -8x minus 1. Unless I tell you that it makes a new function, you need to do that. So I'm going to use f, g, and h for all of my examples right now. They're just not going to fit on the same page. So hopefully you wrote those down so you know what's going on. So I'm going to say h of f of g of x. So that means that I take g and I plug it into f. So -2 4x plus 5 plus 9. This is also the exact same one I just did. So the solutions shouldn't surprise me for this. But this is only these two pieces. Now I need to take what I got, which is this, and plug it into this one. So I'm going to go -8x minus 1 squared plus 6 times -8x minus 1 plus 1. I'm going to expand this out. 64x squared plus 16x plus 1 minus 48x minus 6 plus 1. I'm going to combine like terms, but that's going to be my last step. So I'm going to put h of f of g of x equals 64x squared minus 32x minus 4. And that's what I'm trying to do on these composite functions. Now there is another way to write that. The other way to write that would be h of f of g of x. So we will see it written like this sometimes. We'll also see it written like this sometimes. This is a preferential choice right there. As well as writing it this way or this way is a preferential choice. There is sometimes where it makes more sense to write it like this, and sometimes where it makes more sense to write it like this. So it sort of depends on the application. But these two things literally mean the exact same. Okay? So I'm going to do a couple more examples. I'm going to do h of g of g of g of x. So I can plug the same thing into itself. I'm starting with g, and I'm plugging that into g. So I'm going to do 4 times 4x plus 5 plus 5. Distribute this, 16x plus 20 plus 5, 16x plus 25. Now I'm going to plug that into this one. So I'm going to go 4 times 16x plus 25 plus 5. So 64 plus 100 plus 5, 64 plus 105. And I'm going to take all of that and I'm going to plug it into h. So 64, this should have had an x on it. Whoops. X plus 105 squared plus 6 times 64x plus 105 plus 1. Now I'm just going to simplify this out, so I'm going to multiply it out. I don't know what that is. I'm just multiplying this, so that's going to give me times 105. So I just multiplied everything out. Now I'm going to combine like terms. But that's going to be my last step. So I'm going to put h of g of g of g of x equals 4096 x squared plus 4, 8, 2, carry the 1, 4, 5, 7, 5, 8. Oops. Three, 1, x plus 6, 5, 6, 1. So that's my final answer. So that's what we're kind of looking at with these guys. We'll do some more in class and something that'll be a little bit tougher. Hopefully you can do all 4 of the ones that I left on there.